us remotely. I would really like to thank you, Alessandro, for joining us at 11 o'clock at night or whatever time it is in Italy. So thank you. He's going to talk to us about something that we are all eagerly awaiting, which is Gaia DR4. So Alex, you have 12 minutes for talking and then 3 minutes for questions, and I will interrupt you if you start to really bleed over.
Wonderful. I'll try to breeze through this. Thanks a lot, David, and thanks for having me, albeit remotely. Unfortunately, I couldn't make it in person. So this is about Gaia, and we start with the end, in fact. Gaia has just finished 3 weeks ago, collecting its last observation after more than 11 years of fantastic data taking. This is a summary slide of some of the spectacular achievements that have been obtained by the mission. Just to mention a few, 3 trillion observations of about 2 and more billion objects across the whole celestial sphere. The next big thing coming up is not the end of Gaia observations, but the next data release. There will be 2 more, and so the end of the Gaia mission is actually long to come. Yeah, albeit the spacecraft has completed its job. The next big thing is Gaia DR4. It is coming up no earlier than middle of 2026. It will deliver results concerning the first 5.5 years of data, 66 months. And you see here a brief summary of the onslaught of astrophysical information that could be provided. I will try to touch briefly upon some of the most relevant improvements and things to be expected in Gaia DR4. First of all, better astrometry. You see in the left what was the forecast improvement by square 2 approximately between Gaia DR3 and Gaia DR4 for the parallax determination for the sources observed by Gaia. And as far as we are seeing now, the improvement is actually surpassing the expectations at the bright end for magnitudes by 13 or so. The level of single measurement precision, things are going to get increasingly better, although not as good as one can possibly have. For this, you probably have to wait for Gaia DR5. But you could expect at the transit level uncertainties for a single measurement encompassing on the order of several tens of microarc seconds, which is already rather interesting for what we'll see towards the end. There will be better photometry, improved spectroscopy. Spectroscopy at the bright end will encompass much denser time series for radar velocity work. At the faint end, the faint source spectra will be combined because individually they provide only very low signal to noise below 1, typically on individual exposures. But all encompassing, this will provide spectacular improvements already with respect to what has been delivered for Gaia DR3. And eventually, the first time availability of time series, at least for the astrometry, for the full set of 2.5 billion objects expected to be delivered in the release, will be the most revolutionary aspect of the mission. This will be time series for astrometry, but time series for spectroscopy, time series for photometry, all encompassing. This is a conference focused on knowing the star and then knowing better the planet. Our understanding of the stellar properties will certainly be enhanced by many of the data products provided by Gaia DR4, not just at the level of time series, but also improved estimates of the astrophysical parameters for many of the potential sources of interest. As far as planet demographics are concerned, the expectations are high in the potential for delivery of many orbital solutions corresponding to planets for Gaia DR4. Let me first remind you where we're standing today. Gaia DR3 provided a small albeit still potentially already interesting sample of orbital solutions corresponding to substellar companions, or the 2000 or so. A small fraction of this small sample had potentially orbiting companions with masses estimated in the planetary regime. We are just talking about several tens over the 70 or so, with astrometric signatures in the level of, in the ballpark of a few hundreds microseconds or so. This very first assembled list of planet candidates and substellar companions in the brown dwarf regime was, however, uncovered to be the first relevant sample from astrometry, also showing the most relevant astrophysical false positives that could be encompassed by the technique. Just like transits and radial velocities, also astrometry has its astrophysical false positives of reference, which are, in this case, masquerading as B2s that make the astrometry look like signals due to orbiting companions that are very small, but in fact, they show up as quasi equal mass binaries. As for the four concerning planets, what should we expect then? Well, many more of the orbital solutions of planet candidates than were delivered by the Earth-3. I am not making here an exact estimate because we don't know that yet in exact details. We're still working on it. What you can expect for sure will be significant improvements also in the level of information that will be provided directly to the community. Orbital solutions will be provided both in terms of the fitted as well as the derived parameters, with no need for the community to rederive them. There will be a metric alongside every orbital solution corresponding to a potential planet candidate that will assess the likelihood of it being a true planet or a false positive. We are going to deliver, I don't know how many, but hopefully some multiple solutions. And there will be a very large amounts of acceleration solutions that will point, to some extent, also to the presence of long-period planetary candidates. And most importantly, there will be time series for each of the sources where an orbital solution is pointing to the presence of a potential planet candidate. The planet candidates coming from astrometry are the ones that are most expected, but there will certainly be a significant fraction also of the typically hot Jupiters or very close-in giant planetary companion candidates coming from transit photometry and the RVS as well. The approximate interval in mass and orbital period for the companions expected to be delivered in Gaia DR4 is shown here in this diagram. And the challenge that we will be facing will be indeed to deliver a set of robust orbital solutions where the typical size of the perturbation will be below 100 microseconds, all the way down, hopefully, to the 50 microsecond regime. The candidate catalog of planets, the catalog of candidate planets will be delivered as an extensive list in the form of a table that may not entirely contain all the information that is needed. This is something that has already been done for DR4, and most likely it will be reproduced by DR4, but in DR4. So there will be multiple tables that will have to eventually be queried in order to gain all the information, both from the star as well as the orbital solutions for planet candidates that may have to be assembled. Something that potentially could be eased by providing a unified database with all the relevant information, maybe inside the NASA Planet Archive or its European equivalent in Paris, the Exoplanet Encyclopedia. There is ongoing discussions on how to exactly produce the best set of data products for ingestion eventually when the DR4 is produced. And to conclude, we will have a catalog, a large catalog of candidates expectedly, and they will be primarily candidates. There will also be confirmed planets, but many of them will be candidates. And so we can only expect a very important effort in terms of follow-up observations, spectroscopic, photometric, direct imaging as well, to identify and eventually improve the knowledge of the candidates being real planets or false positives. Some of the work this time will be already done at the level of DPAC, but not everything will be possible, and so there will still be a lot of work for the community to be performed in order to follow up these candidates. And the expectation is that this time the work to be done will be massive enough that indeed coordination would be highly desirable. We have learning within DPAC from the experiences of Kepler and TESS, for example, and the way follow-up programs with other velocities were organized for confirmation of the candidates. So I think eventually, when the catalog is produced, some of these coordination efforts will also be picked up for follow-up of Gaia sources. And I think I can stop here and take any questions.
Okay, thank you, Alessandro. Are there questions? Yeah, right over there, Sean. Give us a second for the mic runners to get there.
Hi, Alessandro. Great talk, and thank you and the whole Gaia team for shepherding this really amazing data set. I'm really looking forward to DR4. I have two questions. The first is related to what you have on the slide right now, the desirability of having coordination for follow-up efforts. I wanted to ask if the team has initiated that, or if is there some expectation that the community will initiate this coordination?
My hope is that this will come from DPAC initially. What we have to do is make a clear assessment of the amount of follow-up work we're going to have to do based on how many candidates will be eventually delivered. And so closer to the data release deadline, so sometimes in a year or so from now, I think something will have to start. And in my opinion, it would be good if it comes as something that sparks directly from the consortium.
Other questions? Question is coming.
Yeah.
Hi, Elizabeth Newton, Dartmouth. I was just interested in more information on what the radial velocity time series will look like.
Okay. Let me go back to here. For example, this is an example of a V time series on the left diagram on the left panel at the bottom. Typically, RVS delivers hundreds of meter per second precision for bright sources with G less than 14 or so. And so you can expect spectacular binary work to be done all the way down to kilometer per second level of amplitudes that will be the ones corresponding to the most massive planets with minimum masses.
One more question?
Are there a question from online? Are there any plans for successor spacecraft?
What?
Are there any plans for successor spacecraft?
Oh, a successor spacecraft. Well, good question. The part of the DPAC consortium is already looking ahead at seeing what can come after Gaia. The one that is being explored right now at the level of potential follow-up is a near-infrared version of Gaia that may fit in the time frame of 15 to 20 years from now at the level of the next large mission from the European Space Agency. This is the present-day view that's coming for success of the Gaia.
Okay, thank you, Alexander. We're out of time, and thank you very much for taking the time so late in the day for us.
My pleasure. Thank you.